Hopefully this will let me write on it today. It's kind of moody some days, so we will see. All right, so like I said, you have your polyatomic ion sheet on the back side of your periodic table. That is a list of them. It is not a complete list. So there are many more out there in the world that we don't have on that sheet. If you need them and they're not on that list, I will provide them for you, or you've got the mighty Google. Okay? So if it's not a test or something like that, you've got Google that you can go to and find them. Fair enough? All right. So I want to look at the rules that are up in the upper corner. So up in the upper corner of that polyatomic ion sheet, there are some rules up there. Do you see them? They're in italics, that sort of thing. The first rule is the most common form ends in the suffix -ate. Okay. So I am just going to pick at random one of those. I'm going to pick sulfate. Okay. So sulfate is on that list. Its formula is SO4. Oh, I told you it's moody sometimes. All right. That is what sulfate looks like. You will find that most common form typically listed in that table that I've given you on the back side of your periodic table. Okay. Now, you need to know the rules for how to get to the other forms. So this is kind of like in foreign language where you conjugate your verbs. We're kind of like conjugating, but we're conjugating polyatomic ions. Okay. All right. So I am going to read those rules. So the first rule was the most common form ends in -ate. Then it goes on. It says the ending -ite is used for one less oxygen. So sulfite would have one less oxygen. So what would its formula be?
SO3.
SO3. The charge does not change. It stays as a -2. The only thing you're doing is changing the A to an I, and you're taking the oxygen from 4 oxygens down to 3 for sulfate. Okay. If I continue reading my rules, it says the hypo plus ite for the 2 less. So if I have 2 less oxygens than the sulfate here, what would my formula be? SO2. The charge does not change. The wording then will be hypo sulfite. See the difference in the words there? Make sense? Have you heard of hypothermic? What does it mean? Yeah, you're too cold. You're below, your body temperature is cooled down to where it shouldn't be. Okay. So you're outside, you stay outside in the winter too long. People can become hypothermic because your body can't maintain the temperature that it should. Okay. Hypo, that prefix means less than. Okay. What means more than? Hyper, like hyperactive or hypertension. Okay. Now, for our wording, though, being lazy scientists that we are, we drop off the HY, and this becomes per sulfate. So the 8 stays the same as the common form, and the per is added to the beginning. And it means hyper, but we just don't do the HY. Okay? What would my formula be for per sulfate?
SO5.
SO5. Yeah, exactly. Make sense? how this works? All right, so let's try it for another one. On there, you will find nitrate. Nitrate, its most common form is NO3 minus 1. Okay, we've given you the common form on that chart. You have to be able to get to these other forms knowing this. Okay, you will always have this listing and that little blurb up there in the corner to help you with this. Okay, so if you freeze up and you're like, how did I get to 8? How did I get to 8? How did I go back and read that? I'm taking you through it now step by step, but you can go through it and do it yourself later on if you need to. This is not going away. Okay, next week or so, we will be taking these polyatomics and putting them together to make formulas. Then we're going to take them and we're going to make acids out of them. Okay, so you have to know how this works solid. And you've got to be able to write these formulas that I'm getting ready to take you through next week in order to do well in the class for the rest of the year. Okay, so we are kind of starting an uphill climb. This is the foundation of which we're building our mighty tower of chemistry. Okay, so you've got to get this, because once we get back from winter break, we go in and we start balancing equations. And if you can't write a formula, there's no way you're going to balance an equation. And then we take those equations and we add math to them. So if you can't write a formula and you can't balance equations, you're not going to be able to do all the math. And that's the whole second semester. So you've got to know how to do these. This is not going to, like, this isn't like electron configuration where like, if I don't get it, I can move on. You're not moving on past this. Like, this is going to be the wall that you have to climb in order to be successful in here. Okay. All right. So let's try this nitrate. NO2, what would that be called? Nitrite. Why? Okay. What would that be called? Nitrite. And this is where some of y'all, with your bad handwriting, you're going to have to clean some of that up, because I have to be able, when I'm grading you, I have to be able to distinguish between an A and an I with your handwriting. And for some of you, you got a hill to climb there. Okay. And then NO4. Why?
Per nitrate.
It's per nitrate, yeah. Some days I wish they would just take this thing away from me and just give me my camera back, take the whole thing off, and I could just write on my whiteboard. Go back old school. All right, so that makes sense. Do you want to run through another one? Anybody? Okay, so that's how these work. I need you to know how to do this. If you're still like, I have no idea what she's doing up there, come and talk to me, please. I will literally get down on my knees and beg you if I need to, okay? And I'm getting old, so it's getting harder to get back up, but I'll do it. All right, so the rest of the hour is going to be spent finishing that project up. If you don't finish your project up, it is due Monday. You're not getting more class time on it, okay? So if you need the ions to take home with you, you can take these cutouts and cut them out yourself and do it at the end of class, but you're not taking my baggies, okay?